I bet you're just like me. A hobbyist or engineering student looking to take the next steps into making a PCB from scratch? Well, this is a JUST10 tutorial on doing that exactly. First things first, we're going to download a PCB design suite called KiCad. It's fully open source and free. Link will be in the description below. Once you get that downloaded and installed onto your computer, what you want to do is open up KiCad. Go ahead and navigate to the top left corner, click new project, give the project a name. See two new files with your project name, click schematic editor, and now we're in. Navigation is super intuitive. You can zoom in and out with the scroll wheel. You can navigate by holding on your right mouse button or your scroll wheel. For this video, we'll be making an adjustable RGB light strip or ARGB strip. Something like this would be good for use with a microcontroller like a ESP32 or Arduino Uno. So we're going to go ahead and click A on our keyboard. It's going to open up the symbol library. This is where you can find all the different components that they have already built into KiCad. So now we're going to type in WS2812. Click that. You should see the symbol and you should see the footprint. Just go ahead and click OK. Place that down. You can click and drag the symbol to move it around, and you can also move these around too by highlighting it and dragging it out the way. Another component that we need for this would be a capacitor. So we can click A on our keyboard again, type C. We can see unpolarized capacitor. Click OK. Place that down. This is going to be a strip, not just a single LED. So what we're going to do, we're going to click this, click copy, paste it. And at the edge of it, you can see that there is a circle. That's basically a connection point. So we're going to click that, place it right on it. And when you drag it, you can see that's actually a connection that's been made. So let's continue, do that again. D out to DN of a strip of 4 adjustable RGB LEDs. So before I do the same thing with the capacitor, we want to give it a value and also assign it a footprint. You can double click on a symbol to edit it, or click E on your keyboard. So with the symbol properties window open, we can go ahead and assign it a value. For this one, we're going to use 100 nanofarads. Before clicking OK, you have to assign this a footprint. Go ahead and click on the footprint field and click on the books. And that brings us to the footprint chooser. Let's type in 0603 into the search bar. 0603 is a standard size for surface mount components like resistors, capacitors, diodes. They're pretty standard, and a good size to use when making a PCB from scratch or for assembling would be 0603_0608. Don't choose this one, you will have a hard time putting that together. So click that, click OK. One last thing we're going to do component wise is we're going to add in 3 male pins. So we're going to type in 3 pin, do male, click OK, place that here. To make it easier to route, click R on your keyboard 2 times to rotate it 180 degrees. So now that we have all the components on our schematic, we can go ahead and grab the capacitor. First, moving the text here, copying and pasting the capacitor 3 more times, so there's 1 for each LED. And now we're ready to make the connections that we need. You can click nodes to activate the wire tool and make connections in between all the components. Or you can go from one end to another end, and as long as the node is touching the wire, it will be connected automatically. You can click W while hovering over a node to activate the wire tool and then start making connections that way as well. Now we're going to go ahead and connect the 3 pins to the LEDs. If you're having a problem with your wires not routing the way you want it to, you can click mid route to kind of lock the wire into that point so you can get more intricate with your routing. So now we can go ahead and start labeling our nets. And nets are basically all the interconnected paths that our power, ground, or signal would be going through. So now let's go ahead and make 3 labels. We're going to make a ground label, a 5-volt label, and a data in label. Click L on your keyboard to make a label. Let's start with ground. Let's go ahead and type in GND into our text box. Click OK, and let's go ahead and place that label on the VSS net. Let's repeat the process for ground and then place that in VDD, and then let's go ahead and get data in and place that on our D in input. Also keep in mind there's ground and 5-volt symbols in the symbol library that you can use if you like, and they should work the same. Now the big benefit with labels is when you're making a more complicated project where you have more components, you can go from something like this to something like this, and it will still be connected the same. So once we do that, we're going to go ahead and click Tools and click Update PCB from Schematic. And then within this prompt box, click Update PCB, click Close, and all our components are right here. So KiCad defaults to a 2-layer PCB, which is what we're going to be using for this, but to change that, we click File, Board Setup, and this is where all of the different settings for your board can be selected and chosen. In order to get a PCB manufactured from a company like PCBWAY, you want to make sure you adhere to their guidelines. I'll go ahead and drop a link in the description with a board with the preferred settings that I use for PCBWAY to make PCB like this. You guys will know what this is soon enough. Just go ahead and drop that follow real quick to stay in the loop. Now we're simply going to go ahead and start laying out our PCB. We have all these components here, and if you look closely, we see the little wires that are connecting to one another. These are called rat's nests, and basically it just tells you what pins or what pads are connected to one another. The rat's nest kind of just helps you to better lay out your PCB in a more efficient way. I want the pins to be on the left side, so I'm going to drag this here, and we can already see that data in should be connected to this right here. So let's move this around here. I'm going to drag this, rotate that with R, and line it up how I want to. Real quick, I'm going to window select the footprints, right click, click Align, and click Align to vertical center. On this right side, you can enable and disable layers from your view. I like to turn off the F fab and the B fab. Let's go ahead and orientate the capacitors properly using the rat's nest to optimize our path. All right, now this is the fun part. We're going to go ahead and start routing our tracks to all our components. Now to route components on your keyboard, you can click X to activate the track tool while hovering over one of the pads or holes. Then you can left click to snap it, or you can click X and keep clicking X to continually snap onto each pad. So we can connect all the 5 volts together. Connect the ground. And now we have to connect the data in. Now unfortunately, we can't really get to there. V on your keyboard to switch layers. You can see in the top. Now we're on the bottom layer. Click X, and now we're routing on the bottom layer. Now to go from the bottom layer to the top layer, we must click V again, and now this adds a via. And vias allow you to make connections to different layers on the PCB. Now once we left click, we're back to red, meaning we're in the first layer again. Click X, and that's now connected. Now we can go ahead and repeat that process for the rest of them. That's some good tips for getting things routed the way you want it. You can click on a track, you can drag it around. All right, now that I have everything routed how I want it, we can go ahead and just preview it. Click View, 3D Viewer, and now we got our board here, but you see it says board outline is missing or malformed. That's a problem. We don't have an edge to our board, so we can define it by clicking on the edge cuts layer, clicking on draw rectangle, or any one of these shapes. We can go ahead and draw the edge cuts. Click 3D Viewer, and then our edge cut is now defined. Now this is another way if you want to add holes to your PCB. You can add an edge cut of a circle and add a hole like that. Now if you want to add text to your board for any reason, you can click one of the silk screen layers, click text, type in whatever you want, place it down anywhere you want. Thing is, this is on the front layer, so you can click on this and then click F to flip it into the back layer. And now if you click 3D Viewer, we'll see our text in silkscreen. Now once everything is connected properly, you should see that there's no longer any rat's nests on the PCB here, and we can go ahead and do a check to make sure that there's no other problems. You can go click Inspect and click on Design Rules Checker, click Run DRC, and we're getting no errors or warnings. Now let me show you what happens if there was an error. Let's disconnect this here, rate that trace. It'll go in and tell us in unconnected items that there's a missing connection there. It's a very, very useful way to figure out what you're missing. But this is all based on the schematic. So if your schematic is wrong, then your PCB will be wrong as well. We can go ahead and send this to the PCB manufacturer. Me personally, I'm a big fan of PCBWAY. I've gotten about 3 boards made by PCBWAY, and they have a pretty intuitive tool within KiCad that you can use to get your board right from the software to their website and get a quote. Let's just make sure we save the project. We go to plugin and content manager, and I go in and type in PCBWAY. I already have it, but it'll say install here for PCBWAY plugin for KiCad. Now when you go in and click on PCB editor, there should be something that pops up here, a little extension in a way that says PCBWAY plugin for KiCad. Now left click on that and it'll take you right to the website. And right here we can see we can get 5 boards made for $5 per board, shipping $20, which is not bad compared to back in the day where, you know, you'd have to have a minimum order quantity of, I don't know, 100 boards or whatever it was. And now you're ready to make your own PCB from beginning to end. Now this was a pretty fast tutorial. 10 minutes to learn PCB design is there's a lot of intricate parts to PCB design. So if you guys want a full in-depth video from beginning to end of a more complicated project like making an ESP32 microcontroller, leave a like, comment, drop a follow if y'all want to, subscribe, whatever, man. Appreciate you guys watching this video, and also toss in my Discord below so y'all can get private help just for me. Well, I'm not a professional, but you know, I made some pretty cool stuff here and there. All right, be easy.